So given a problem on a simple RC circuit, so at first let's solve a circuit with a no initial values. Given a formula, we already know that the capacitive reactance is equals to 1 over SC using a Laplace rule. And the voltage divider theorem in this circuit is equal to for the voltage of capacitor, since we are finding the voltage of capacitor or VC on a time domain is equal to Vs times Xc over R plus Xc. It is obtained by using voltage divider. At first, the first thing we will do is to convert the circuit into Laplace circuit. So since we have a voltage source of 1, it is equal in the transform of 1 into Laplace transform is 1 over S. And since we know that the capacitive reactance is equal to 1 over Sc, so the 3F becomes 1 over 3S. Since we have no initial value, it is equal to 0. Actually, the voltage on capacitor using the voltage divider, since as we notice, it is equal to X over R plus X. It's only the ratio of the impedance of the component of the circuit. So plugging in the value, we can simply rewrite this over 1 over 3S over, since the resistor value is 2 ohms, it is 2 plus 1 over 3S times the voltage source, which is 1 over S. So after that, we can simplify this equation to more simplified answer. So we can just multiply 3S over 3S to cancel the denominator. Applying that, we have 1 over 6S plus 1. So 1 over 6S plus 1 times 1 over S, which is the voltage of capacitor in a S domain. So as we notice, we can reduce that into 6S plus 1 times S. And our primary goal here is to get the voltage of capacitor in terms of time domain. Since we have a simplified Laplace or on a frequency domain equation of the voltage of capacitor, we can use a partial fraction in order for us to solve the inverse Laplace transform. Using the partial fraction is equal to A 6S plus 1 plus B over S. As we already know how to do the partial fraction, our primary goal is to make the denominator is equal to 0 in order for us to get those constant A and B, which is for A, your S must be equals to 1 over 6. Why? Because negative 1 over 6. Why? Because if 1 over 6 is multiplied by 6, it will be equal to negative 1. Then plus 1, it is equal to 0. So negative 1 over 6 must equal to S for A. So 1 over 1 over 6, or 1 times negative 6, 1 is equals to negative 6. It is equal to, definitely it is equal to A. And for B, it's easy. Just let the denominator is equal to S is equals to 0 in order for you to substitute the 1 over 6, 0 plus 1, or B is equal to 1. So we have now the value of constant. We can directly substitute. So substituting the constants. Since for A, we have negative 6, 6s plus 1 plus 1 over s. As we notice here, we can factor this denominator in order for us to cancel this 6 since we have no identity in this equation. So doing that, respectively, this equals to negative 6 factoring each to 6, which is s plus 1 over 6 plus 1 over s, which will cancel. The 6 will reduce into s plus 1 over 6 plus 1 over s. Now it has a identity of this is the exponential identity, which is e raised to negative 160, and the u of t. So this part is negative, by the way. So arriving into substitution of a time domain of the voltage of capacitor. So inverse Laplace of this is negative e raised to negative 16 t, and this is ut plus ut function, since it is already a function of. Then simplifying this into more relevant, negative e 16 t plus 1 all over times it into u of t. So this is our final answer. It is the Vc of t. So let's proceed on the circuit analyzation via Laplace. So the basic concept is the capacitive reactance and inductive reactance, which is equals to 1 over Sc, and X is equals to Sl, as we already know that the total current flowing here is equal to the total voltage over total impedance, which that impedance is composed of the basic resistance, which is the resistors, and the capacitive inductance and capacitive reactance, as I mentioned before. And we already know that we need again to recall our knowledge in understanding the circuit using a different circuit theorems like voltage divider and Kirchhoff's current law and Kirchhoff's voltage law. And the condition in this problem is to find the ILS, which is the current on the inductance, and the ILT at t equals 0 or t during 0, which the switch is normally open. So when the switch is normally open, we already know that this circuit will be converted on only this circuit, and storing those initial values and initial voltage on the capacitor and the inductor. So for doing that, we must close first the circuit. Let's consider the conditions at time before 0, where the switch is normally closed. So when the switch is normally closed, we will know that this is a open circuit and this is a short circuit. And now getting these values, therefore this is 10 over S, and the inductor is 1S or S. We must define the voltage, the initial voltage here, get the capacitor voltage and the inductor voltage a time before 0 in order for us to know the initial voltages. We can get now the capacitor voltage since we have our total voltage, by the way, is 10 volts times the R1 over R1 plus R2. Again, it's voltage divider, or simply it equals to 5 volts. It is equal to the initial value on the capacitor. In solving for the initial voltage on the inductor, we must found first the current rotating on the circuit times the inductor. So, understanding the current rotating on the circuit, it is simply the total voltage over the total resistance, which we are considering that this is a short circuit and this is an open circuit. So, only this will be the total resistance. So, 10 over 4, we already know that it is equal to 10 over 4 is equal to 10 divided by 4, 2.5 amperes times 1 Henry. So, 2.5 volts is the initial voltage on the inductor. We already found the initial voltage on the capacitor is 5 volts and 2.5 volts on the inductor. So this is our equivalent circuit on Laplace because the switch is now open. So the inductance is equals to, and we already got this value, so we're just writing it here, that the XC is equals to 1S. Both is equals to 2 ohms. We already know the initial values. 5 over S, right, and 2.5 volts. This is now the Laplace equivalent circuit. At t equals 0. Now we are at the condition at where the switch is normally open. So now we can search for the IL of S, where it is equal to V of S over total impedance Z of S, which is equal to the 5 over S plus 2.5 4 plus S plus 10 over S is clearly, so we can simplify this by multiplying again S over S, basic algebra rules, which result to 5 plus 2.5 5 plus 2.5 5 plus 2.5 S over S squared plus 4S plus 10. And factoring this, we will get S plus 2.5 S. 5 plus 2.5 S over S squared plus 4S plus 4 plus 6. Now I split up this is for we have a identity. Later I will show what is this identity. Just factor it the denominator to find a way to get a similar identity on the Laplace table. And proceeding, so the simplified method is 2.5S plus 5 S plus 2 squared plus 6. As we see, the only problem here is our numerator. Splitting up in this to more simpler equation. 2 squared plus 6. As we see, we got a same s plus 2 here. Remember that e negative at cos bt is equals to s plus a squared plus b squared. We have a clearly same function here. So now our job is just get the inverse transform of the inductor, which will result to ILT is equals to 2.5 e raised negative 2t, since this is our a. Cosine, remember this is 6, must be squared, so on the reverse process we will square. Now we finally got the ILT, or the current on the inductor in time domain, which is 2.5, using this identity by inverse processing this using inverse Laplace transform of this. By the way, this is our answer. Let's begin solving a problem constructed by use Laplace transform to solve this following equation with initial values and find the inverse Laplace transform of y. Given a y raised to double prime plus 5y prime plus 6y equals to 0, given a initial condition. This is initial conditions. Y0 equals 2, y prime 0 is equals 3. And we already knew that Laplace of y prime is equal to SLy minus y0. Therefore, the Laplace of y double prime is equal to s squared Laplace of y minus sy0 minus y prime 0. Now, this part now is equals to, we can use a Laplace transformation. Now it is equals to y double prime Laplace of y double prime plus Laplace of 5y prime plus Laplace of 6y is equal to 0. So now we're gonna able to substitute this following equations to this part, or this part. So let's proceed. Let's go to the first. Directly substituting those values will give us a answer of squared. Now I'm solving it now. Y minus sy0 minus y prime 0, since it is the property of y double prime. I oftenly put this quantities for avoiding a mixture between numbers or equations. So we have now a 5y prime, substituting this y prime, so it is multiplied by 5, gonna be s y minus y0. In the simplest equation, no identity at all, the L6y. And now we're gonna rearrange these terms for a easier equation. So it is equal to s squared ly plus 5s ly and then minus that's why I separate those equations with Laplace quantity onto these initial conditions, which has a given value, for me to directly substitute those given values easily. So proceeding, we have, as we see, this sy0 is equal to y of 0, 2 will be equal to, break down into negative 2s, and this y prime 0 is equal to 3. So since it has no multiple, it's gonna be stay on 3. And this 5y of 0 is equals to 2 y of 0 times 5 is equals to negative 10, equals to negative 2s minus 13. This part, negative 2 is 13. This part, I just substitute the initial values. So rearranging and rewriting these terms will result into, pardon my handwriting, 5sly plus l6y minus 2s is 13. I can simply equate it since it's negative, plus 5s ly plus l6y is equal to 2s plus 13. As we observe, we can now do separating those value into, factoring those terms into Laplace of y. Doing that, so Laplace of y is equal to 2s plus 13 over s squared plus 5s plus 6. As we observe, we can now do a partial fraction on that. Doing a partial fraction, we must first factor this denominator in order for us to do a partial fraction. So, as searching a factor on that, you can use a quadratic equation or directly think about what number comes when you will add result into 5, and when you multiply, it will result to 6. So obviously it is 3 and 2. So our factor is 3 and 2 equals to 2s plus 13 s plus 3. When you do a quadratic equation formula, it will result into same answer. Just a inverse sign since it is already on. So proceeding on a partial fraction, it is equal to a over s plus 3 plus b over s plus 2. Now again, we're gonna think a number that will make the denominator 0. And therefore to get the value of a and b and substitute into this equation. Obviously, our two values of s is negative 3 for 0 denominator in this part and negative 2. Proceeding, for a, let s equals to negative 3, and for b, let s equals to negative 2. And after solving that, we get now a is equals to 7 and b is equals to 9. Why? Because I directly substitute this value to this. So upon checking, you will get the same answer. And now, using those obtained value where a equals to 7 and b equals to 9, we can now do a, since it is 7 equals to 7 over s plus 3 plus 9 over s plus 2. So it's 9. So as we observe, we already found a identity on this. So using a inverse Laplace transform, it is, as we clearly what is this identity? Since this is the numerator is 7 and s plus 3 is the denominator, it is the exponential function, which is raised to negative 3t. So it is 7e negative 3t plus, with the numerator of 9, 9e negative 2t, all is multiplied on ut. This is the answer, the inverse Laplace identity of this. So let's start solving this problem number 1. Given these problems, directly substituting the Z transform identity. So at first, we have this problem. Let's solve that. We already know the identity of this f of n is equals to z is equals to 0, since the delay is equal to 0, as we see. Yes. We have a delay equals to 1, so it's inverse of z. Yes. Delay of negative 2. For more simplification, we will have a value of 1 plus 1 over z plus 1 over z squared. Cut. Solving the second problem, as we observe, we already again know this kind of this transform. So directly substituting, we have 1 over 1 minus z raised to negative 1 plus 1 over, so we have an a here, belongs to the z part. We can finally arrive at this answer, but for multiplication, we can proceed to 1 over 1 minus 1 over z plus 1 over 1 minus a 1 raised to z. And for the simplification, we can just multiply this to z over z. We can finally have a more simplified answer, z minus 1 plus 1 over z minus a, z. Okay na. Given this identity, nun is equal to z raised to negative 1 minus z negative 1 plus, again, the previous identity, we have a 1 minus z negative 1. So again, for more simplified answer, we can multiply it by z over z to cancel the ones. But before, we will split this equation. This 1 minus 1 over z. So finally, we can now multiply it into z over z, results into z times 1 over z is equals to 1, z minus 1 plus z minus 1. So now we will solve a problem involving a inverse z transform. As we see, it's already on a z transform. So our goal in this problem is to get the end domain of this problem. So let's proceed. At first step, we will do the factoring on its denominator. So we will think a basic concept on factoring. By the way, the factoring formula, for those who forgot to factor out this denominator, is equal to negative b plus minus square root of b squared minus 4ac over 2a. So this quadratic equation formula for factoring is applicable to this problem. But for the purpose of time management, we will directly take a factor of this problem. It's 2z minus 1. Z minus 1. After that, we can do a partial fraction in this problem. Doing a partial fraction, you can get a 2z minus 1 plus b z minus 1. So the partial fraction concept is we need to get those values a and b by letting this denominator is equal to 0. So first, let's solve at a. For a, we have let z is equals to 1 half. Why I chose 1 half? Because we have 2z here and the quantity negative 1. So negative 1, we must multiply the 1 half to 2 in order for result a 1 minus 1. So the denominator is equals to 0. Plugging in the 1 half, 1 half minus 1, this equals to 1 half negative 1 half, or 1 half times negative 2 1, and when this is 2 negative 2 2, or a is equals to negative 1. And for b, a more simpler equation, we can just let z is equals to 1, so it will 1 minus 1. For b, we got let z is equals to 1, so it will result to 1 over 2 1 minus 1, or 1 over 1 is equals to b, or 1. And this value we will plug in on the, or direct substitute to the partial fraction identity, which has negative 1 for a, 2z minus 1 plus 1 over z minus 1. So as we observe here, we will not be able to get a z transform identity because of this value. So one way to get a proper identity is to find a way for this equation. So at this case, we need to divide it into this directly to a long division method, or we can do another partial fraction doing the h over z. So doing first the dividing this h of z to z will equal to 1 from this identity z. We'll divide it into z, so it will result to 1. And still the denominator 2z minus 3z plus 1 are also equal to 1 over 2z minus 1 z minus 1. And doing again a partial fraction, 2z minus 1 over z minus 1, and this to be plus this 2z minus 1. So for a, let's write this first, equals to 2z minus 1 plus b z minus 1. So again, letting the value equal to 0, the denominator, you can assign the, for a, z is equals to 1 half, and for b, z equals to 1. Again, you can get a 1 over 1 half minus 1, or simplifying more, negative 2 a. And on b part, we'll have a, for b, 1 over 2 times 1, 1. 1 over 1 is still 1 for the taken identities. Will proceed on equals to negative 2 over 2z minus 1 plus 1 over z minus 1. Finally, we can just let factoring this enable for you to cancel this since we have a complicated identity here. Negative 2 z over 2 minus 1 or z minus 1 half will have a negative 1 over z minus 1 half. Writing the equation, we have a negative 1 z minus 1 half plus 1 over z minus 1. And this can h of z over z minus 1 half plus 1 over z minus 1. So we see we have still a z here. So the best solution is to multiply again z over z to cancel this. Now we have only a h of z is equals to negative z minus 1 plus z minus 1, or the inverse transform of this is equal to x of cos. Choke ako eh.
Go.
So finally we got this identity. So we can now directly inverse transform this, which is equal to 1 half this n un plus, since we have this no u of n. So again, we have given a inverse Z transform problem. So as we notice, we have xz here. To cancel it, we must multiply it into x of z over x of z. X of z cancel. We have now a y of z is equals to 1 plus z negative 1 plus z negative 2 multiplied this by x of z. Simplifying, x of z plus x of z negative 1 plus x of z negative 2. Only we're searching for y of n, so we can now directly inverse it. So we have a x of n and x of n with a delay of 1, and the x of n with a delay of 2. So for solving involving a problem of block diagram as instructed, you must find y of z over x of z, then use a long division method to find y of n. So at first, we'll follow the block diagram. So as it said that x of z is going to this plus sign. So x of z plus, since the x of z is going to this system or h, we have z negative 1 times z negative 1 is equal to z negative 2, where it is a property of x of z. So as proceeding, negative 2, where it is a property of x of z. here. So as stated on the block diagram, we have a feedback property y of z into z of negative 1. So writing, we have a feedback of z negative 1, which is property of y of z, or is equal to the y of z, which is the output. So breaking it to more simplified term, it is equal to x of z. Factoring this to x of z, you can factor out to 1 plus z negative 2, and then it is equal to, factoring this to y of z, we will obtain y of z. Since we already equated it, the sign will be opposite since this equal sign. 1 minus z negative 1. So getting now finally the y of z over x of z is equal to, since this is the property of y of z, must be here, basic algebra rule, using basic algebra rules, property of x of z is on the numerator part. So that's it. So now we will proceed on the long division method. So as we seen, it is the simplified form of this block diagram. For continuation, we must now find the long division method of solving dy of n to this block diagram. So as we did all earlier, we simplified those equations into y of z over x of z in order for us to do a long division. Now answering it is equal to 1, then times this value will equal to 1 minus say negative 1, then it is a subtraction, so the sign will be reversed, getting a answer of 0 plus z negative 1 plus z negative 2, since it cannot be solved since it has a different exponent, so it is a rule. So dividing this z negative 1 to 1, syempre it's equal to z negative 1, and then again multiplying z negative 1 to this number, we will get z negative 1 minus z negative 2, since z negative 1 times z negative 1 is equal to z negative 2. And again, reversing the sign because it is a subtraction, get 0 plus 2z negative 2, and again dividing it to 1, result to same answer. So as we observe, it is a non-terminating 2, non-terminating, but the exponent is decreasing since it is inverse, and this part is exponential. So you see, plus 2z negative 2z negative 2 minus 2z negative 3, 0 plus 2z negative 3, getting this answer 1 plus z negative 1 plus 2z negative 2, and dot, since it is continuous function for a non-terminating. It's the answer. What if we are asked to find yn with this equation? The first thing we're gonna do, since this y of z is only equal to a over 1 over 1 minus z negative plus z negative 2, this part is what we need in order for us. But we are asked to find yn. So the first thing we will do, since we don't need this part, is only multiplied by y over z, and then now cancel this part. Now this part is being cancelled, but it is multiplied by this part. Proceeding, it is x of z is equal to 1 minus z negative 1 plus z negative 2 quantity y of z. Performing the operation equals to y of z minus z negative 1 y of z plus z negative 2 y of z. We observe, we can now just equate it into y of z in order for us to get the yn. So y of z is equals to x of z. Since we equated it, the sign will be reversed. So plus z negative 1 y of z minus z negative 2 y of z. Z negative 2 y of z. So now we can directly transform it into y small y of n is now equal to, since no delay, it is only x of n. It is a delay, so it equals to y, this property of y, don't forget, delay of 1 since z raised to negative 1 minus y of n with a delay of 2. So this is the final answer. So we again able to find the y of n. So before proceeding on solving a problem involving a plotting poles and zeros, we must first define those basic concepts involving plotting poles and zeros. So as we already know, poles, it is a value that will make the denominator equals to 0. It is a value of z that makes the denominator equal to 0. And the zeros is a value of z that will make the numerator is equal to 0. Given the plot, as we already know, this part, which is the y-axis, is the imaginary part. As we already know, on the complex number, it's equal to j. In this plot of x-axis, which is parallel or horizontal, it is equal to x, or it is the real part. So let's solve a problem involving a poles and zeros. So example, this number 1.7038 plus 0.71. So our aim this is to make first the denominator and the denominator is equal to 0. So as observed, it is the real part, it is the imaginary part. So we must have a 1.7038 negative, so it will be equal to 0. So let's do this. It is located here since it is a negative, positive side, negative side. This is for the real part and the imaginary part. So this is 1.7038. Then we are given a j, or imaginary part, of 0.71. This is a 0 since it is a part of numerator, and 0.71 part of denominator. As same as the denominator, we have a 0.71 on the imaginary part. So it is poles and 0. This value is, this 0.71 is composed of poles and 0. And the real part is 0.2038, so we place here. And don't forget, it is a pole. So wrapping it will result into this. For a more precise for this, as we see. So for another example, we have 10 plus 15j over 20 plus 16j. So we have a real part of 10 and 20, and we have an imaginary part of 15 and 16. Proceeding, plotting on a coordinate, you can plot now the 0 of 10 since numerator is 10 and the poles of 20. Now the imaginary part of 15j. 15j since negative must be located here, and for it is numerator, so it is a 0. And for the 16j, since it is denominator, so it must be x. So it's for 15j, 16j, 10 plus 16j, and 16j plus 20. As we observe, we form a two triangle. We can get the hypotenuse of this triangle by using Pythagorean theorem, since we have already given a side of B and A for adjacent and parallel.